In applications of sets 2, we're going to talk about the inclusion-exclusion principle. There's always this awkward time when you're talking about Venn diagrams where you get down to having all of the things that are in A, all of the things that are in B, and then the things that are shared, and you're trying to figure out, well, how many are actually just in A, how many are just in B, or how many are in all together. So the inclusion-exclusion principle has to do with those numbers and how we use them to find values inside Venn diagrams. If I have, for example, a Venn diagram that looks something like this, and it sets B and C, doesn't particularly matter what they are, and there's 49 in this region, 16 in this region, and 14 in this region, we want to figure out how many total students are actually represented. Well, if there's 49 and 16 and 14, we can use that to figure out how many students there actually are. Well, there's 49 plus 16 plus 14. 16 plus 14 is 30, plus 49 would be 79 total students. Well, that is the inclusion-exclusion principle. The inclusion-exclusion principle is talking about including all the things but excluding a certain number of repeats so that we can figure out the number. In general, the inclusion-exclusion principle looks like this. The number of A union B, or all of A and B together, is equal to the number in A plus the number in B minus the number that is shared. Think about it. If we have all of them together, we put all the elements in a lump, we don't use repeats. So this intersect B over here is including those repeats, because if I count all the elements in A and all of the elements in B, if there's two that overlap, if I subtract those two out, they're still accounted for. Let's use the inclusion-exclusion principle. A school finds that 430 of the students are registered in chemistry, 500 registered in mathematics, and 225 are registered in both chemistry and mathematics. How many students are registered in chemistry or mathematics? Let's draw a Venn diagram. It looks something like this. Chemistry, mathematics. There are 500 total registered, or 430 in chemistry, 560 in mathematics, 225 are registered in both chemistry and mathematics. Remember, we're going to start from the middle. So if 225 are in the middle here, and total in mathematics, there's 560. To figure out this part, we do 560 minus 225 is going to give us, let's do a little math here, 560 335, and we've got over here 430. So this is just mathematics, this is chemistry, 430 minus 225, because those are the ones that are registered in both. And that's going to give us 205. Did both calculations at once. And so we can figure out how many are registered in chemistry or mathematics. That's total, registered in chemistry or mathematics. We've eliminated the repeats, and so the total number of students would be 205. The number in just chemistry, plus 225 registered in both, plus 335 registered in mathematics. That's going to give us a total of 765 students. It's about basketball, soccer, and those who play both. So I'm going to draw my Venn diagram, and I know that it has two circles because it's talking about basketball or soccer. I'll label them basketball, soccer. And so if 24 play both, that is what's shared. Well, if there's 80 athletes that play basketball, we do 80 minus 24, which is going to give us 56. And we have soccer, we have 60 athletes minus 24. is going to give us 36. We can figure out how many total there are because what's represented here is just those who play basketball, those who play both, and those who play just soccer. So total athletes, how many play basketball or soccer, is all of them. So we have total 56 plus 24 plus 36. So that's going to be 60 plus 56 is going to be 116. It's the inclusion-exclusion principle. Because notice, we took the total number of athletes in soccer or basketball, subtracted the amount that was in the middle, and we figured out what it was for these other spaces over here, these other regions. Here's an application of this inclusion-exclusion principle just doing with numbers. If we have the number in A, the cardinality of A is 15, meaning there's 15 elements in A, and the number in B is 32, so there's 32 elements in B, and the number of the total is 41. Let's find A intersect B. So we're going to set up the equation here. It looks something like this. The number of A union B is equal to the number in A plus the number in B minus the number in A intersect B. We fill in what we know. Do we know A union B? Yes, we do. It's 41 equals the number in A is 15. The number in B is 32 minus what we don't know. So we'll call it X because we don't know what that number is. And we'll simply solve this equation. 41 equals 15 plus 32 is going to give us 47 minus X. Well, obviously it comes out to 47 minus what equals 41, so X is equal to 6. So that means the number in A intersect B is equal to 6. That's as simple as it is. We simply set up the formula. You can try this next one on your own, see what you get. Let's talk about the percent inclusion-exclusion formula. The percent inclusion-exclusion formula is much the same. The percent of A union B is equal to the percent of A plus the percent of B minus the percent of A intersect B. It's the same thing, except it's just having to deal with percents. This would be useful for surveys or pie charts or things of that nature. Here's an application of this. The U.S. American Association of Blood Banks reports that about 44% of the population has the A antigen, 15% has the B antigen, 4% has both the A and the B antigen. We're going to use the percent inclusion-exclusion formula to find the percent of the U.S. population has the A antigen or the B antigen. If we use the percent inclusion-exclusion formula, which is this one up here, the percent of A union B is equal to the percent of A plus the percent of B minus the percent that is intersected or has both. When I solve this, I get 44 plus 15 minus 4 is equal to 55%. 55% of the total population has the A or the B antigen. That's as simple as it is. See if you can do the next one on your own. Let's move to example 6. I really hope you're doing these examples because they can definitely be helpful in understanding these formulas. The next one is a table like you might see after doing a survey, which we will do. A survey of men, M, women, W, and children concerning the use of internet search engines Google, Yahoo, and Lycos yielded the following results. I have a chart outlining what each type of server or each type of search engine had in terms of their users in this survey. When I look at something like this, it's really interpreting this data. So I want to know how many what? Well, it's because it's a number. How many women intersect with Yahoo? So how many women use Yahoo? Well, I go to women, I go to Yahoo, and I get 280. The sets intersect because the set of people who use Google intersects with the set of children, or the set of women intersects with Yahoo. That's what we're doing here. How many use Google? And then I've got this C prime. So that means how many are not children? So outside the set of children, how many use Google are not children? Well, so I go to Google because these are the only things that I'm concerned about, and I get rid of the children because I'm not counting those. Well, it'd be 440 plus 390, which gives me a total of 830. So you see how this works. The next question. Remember, we're going to start from the inside parentheses. We're going to start it in the middle. Google union Lycos. So I want all of this. Let me erase part of these here. I want all of these here. I want Google and I want Lycos, so I have all of those. Google and Lycos. And I'm going to intersect that with men. So I want just this part here. Men who use Google and Lycos. So the union of Google and Lycos where it intersects with the men. So just those. So that's going to be 440 plus 275 is going to give me 715. So you see how this works. There's 2 down here at the bottom. Actually, there's 3 down here at the bottom. See if you can do those. Because we're really just intersecting these sets of people that are outlined in this chart. So see if you can figure out those. Thanks for watching. We'll see you next time.